Hello everybody, here we're taking a look at exit ticket 1.1. So first things first, I'm going to go ahead and write my name up top here. And now I'm going to get started. So yesterday we took a look at similar figures. So in this case it says quadrilateral ABCD is similar to RSPQ. Identify the corresponding sides and angles. And so notice if these two figures are similar, then this one here is rotated a little bit. Doesn't look the exact same as this one on the left, but it is. And so here we have side AB, and that would align with side RS. And we know that to be true because AB comes first, so does RS. So corresponding sides, AB and RS. Okay, what comes next? B to C and S to P. So those two sides would correspond as well. And then we look at C to D and P to Q. Notice we're just going in order here. A to B, B to C, C to D. Same with this figure here. And then finally, we're going to end with D to A and Q to R. All right, now we're going to look at corresponding angles. So here we have angle A, and that will align with angle R. And we have angle B, and that would align with angle S. And we can just go in order here. So I like to say angle equals, because remember the angles are equal. And then we have R. I might as well just write all these out. All right, so we have our corresponding sides and our corresponding angles. And the question asks, if angle A is 120 degrees, then what is the measure of angle R? So remember, we said that angle A is equal to angle R. So if they're equal, then that means it's going to have the same measure. So if angle A is 120, then angle R is also going to be 120 degrees. And if we look at our picture, that makes sense, right? If this was 120, angle R looks the exact same because it is. It's also going to be 120. All right, let's move on to 1.2. All right, so the questions here are asking, determine if these shapes are similar. So let's go ahead and jump into this first one. To compare similarity, I need to see if this side multiplies by the same thing to get to the new side length. And if this side length here, 7, multiplies by that same number to get to the new side length down here. Okay? So when we're trying to figure out what number we multiply by, we're going to go ahead and divide. You can also think about it as we are trying to see if these ratios are equivalent. So we have LM is lined up with P to Q. And remember, we're going to go ahead and write PQ side on top when we write our ratio. So I'm going to write it as 24 over LM, which is 12. So we have our image or our copy over the original. Okay, that's what we have here. And so 24 divided by 12, or 24 over 12, is equal to 2. We'll do the same thing over here. we have 10 over 7, right? Because side PS aligns with side LO. So we can do 10 over 7. And notice when we do 10 divided by 7, it does not give us 2, right? We need to have 14 over 7. So let's go ahead and use our calculator. 10 divided by 7 equals 1.43. So if you want to show your reasoning, you could do 1.43 does not equal 2. So we multiplied this by 2 and multiplied this by 1.43. And they would need to be multiplied by the same number, so they are not similar. All right, let's move on to the next one. Let's go ahead and zoom in here because it's kind of tough to see. All right, so this time we're going from 4 over to 5, it looks like. Going from 8 over to 10, and from 6 to 7.5. So I'm going to write it as 5 over 4, 10 over 8, finally 7.5 over 6. In all these examples, we're taking our image or our copy and writing it over the numbers of our original to see what we have to multiply our original sides by to get to our copy, our second figure. So 5 divided by 4, that's going to give us 0.8. So we're multiplying 4. Whoops, excuse me. I did 4 divided by 5. So we do 5 divided by 4. 5 divided by 4 gives me 1.25. So we have to multiply 1.25 by 4 to get to 5. Next, if we do 10 divided by 8, that's the same thing as 5 over 4. So again, we're going to get 1.25. And let's do 7.5 divided by 6. 7.5 divided by 6 also gives us 1.25. So notice we get 1.25 as the multiplier for every single one of these numbers here. We multiply each of them by 1.25. That is our scale factor. So since we have the same scale factor, the same number that we're multiplying each side by, then we can tell that they're in proportion. When you have equivalent ratios, then your shapes are indeed similar to each other. So this one we could say yes, and then we have our work shown above, and we could even write equal ratios. All right, hopefully this helps. Thank you.